So I want to multiply these two matrices together. The first thing we want to do is to check dimension-wise whether it's possible to do the multiplication. Well, this first matrix is a 3 by 3. This second, we could call it a column vector, but it is still a matrix. It's just a 3 by 1 matrix, 3 rows by 1 column. These inner dimensions match. So yes, we can do that multiplication. And the answer for what we're going to get is a 3 by 1 matrix. So when I do this multiplication, I know that we're going to end up with something that is 3 rows by 1 column. Now, I didn't give us values for X, Y, and Z, and I did that on purpose because I want to look at what happens when I take this matrix and multiply it by a generic vector, X, Y, Z. So in this first row, that's going to be row 1, column 1, which means I'm going to take row 1 and multiply it element by element times column 1, entry by entry. So I'm going to have 2 times X plus 1 times Y plus 1 times Z. My second row here is going to be 0 times X, 3 times Y, plus 4 times Z. And my last row, 1 times X, plus 0 times Y, plus -2 times Z. If I compare these two things, this matrix represents the coefficients of the X, Y, and Z over here. And one of the things that that's going to allow us to do is if I started off with a system of equations that looked like 2x plus y plus z equals 4, 3y plus 4z equals -2, and x minus 2z is equal to 7, then I can write this system of equations in a matrix form that would look like, since I know that this matches with what we have here, the left-hand side of this equation is this matrix of coefficients, 2, 1, 1, 0, 3, 4, 1, 0, -2, times the vector that contains my variables, x, y, z. And that's equal to this column vector on the right-hand side, 4, -2, 7.